With that, we can move on to zero-shot text-to-image generation. I'm sure you have heard about DALL-E. It's like GPT, or it's exactly GPT-3 architecture, but it knows about images as well. And it's trained on 250 million image text pairs from the internet. This is an assignment for you to watch that video, so I'm not going to spend too much time on this paper. But what is the task? The task is not new. It was transforming text to images. And we just saw two methods of doing it. We saw two methods based on generative adversarial neural networks. But what is new here? It is new because it's going to end up being zero-shot. You don't do any fine-tuning on the model that is learned. And we learned that GPT-3 and GPT-2 were also zero-shot. But here there is a nice idea that I want to emphasize. If there was a way for us to tokenize images the same way that we tokenize text, and what do I mean by that? We were taking sequences of characters and we were turning them into integers, or we were taking words or subwords and we were turning them into sequences of integers. Is there a way to transform an image into a sequence of integers? And if you can do that, and if you assume that that's a problem that is solved, then all you need to do is concatenate those sequences of integers for your text and the sequences of integers for your image, concatenate them together. That's going to give you a long sequence, and then do next token prediction in a language model fashion. And then you can start generating. You can say, this is my text, keep generating the next pixels. And then it's going to generate images, or realistic looking images, or images that is just generating on its own. So that's our problem. Given an image, which is going to be sort of high resolution, 256 by 256 by 3 channel. Here I'm writing R, but images are actually quantized to integers. You're going to have 0, 1, 2 up until 256. And that 256 has nothing to do with this 256. That's just the quantized version of every single vector. So the reds are going to be from integers from 0 up until 256. And that 256 is actually 8 bits, 2 to the power 8. It's going to give you 256. And this is just your resolution. But anyways, your images, you are able to quantize them, but then that's going to end up being a high resolution. Here you're going to have from 1 or from 0 up until 256 to the power 256 by 256 by 3. And it's going to end up being a very long sequence once you flatten it. There is this idea of Gumbel softmax. It has to do with variational autoencoders. It's a discrete variational autoencoder, and we're going to learn about it, I would say, next session or the session after it. And its job is to increase the number of tokens to 8,192 and reduce the resolution to be 32 by 32. It's the same story between character-level language models and word-level language models or subword-level language models. For character, you have very few characters here, but you're going to end up with very long sentences. For word and subword level language models or tokenization process, you're going to end up with a long vocabulary, but shorter sentences. It's the same story here. You're reducing the context by a factor of 192. There's going to be an encoder, which is going to give you give it an image, and it's going to give you the tokenized version. The decoder is going to go the reverse route. If you give it the tokenized version of an image, it's going to give you the original image back to some approximation. It's not going to be perfect, but you're going to get that to some approximation. Now it's solved. You have a sequence of tokens, that's your image. You have a sequence of tokens representing your text, concatenate them, and then do next token prediction. Is DALL-E clear? I need to hear a couple of yeses. Okay, perfect.